Okay, here we have ionic bonding, the worksheet that we did today in class. So what we're trying to do is figure out how these elements combine together in an ionic bond. To do that, we are going to look at their valence electrons. To figure out the valence electrons, we're looking at the electrons in the outer orbital. So, for example, with Na, we have the orbitals. We have the first orbital, second orbital, and the third orbital are the energy levels. The first one gets 2 electrons, the second gets 8, and the last one gets 1. This should be a review from your 8th grade year. I'm drawing them like this. Now, with the valence electrons, it's the electrons in this outer level. Atoms want 8 in their outer level. So either sodium can lose this 1, and that means the outer level would have 8, or it can gain 7. Now, it's easier to lose 1, so that's what this element is going to do. On our periodic table, we can list the number of valence electrons. This column will have 1, this one will have 2. We're going to skip this section. This one has 3, 4, 5, 6, 7, and 8 valence electrons. So on our worksheet, we are not going to draw all of these circles and loops because really all we care about are the valence electrons. So that's why we draw it with just the dots here. If we look back at our periodic table, chlorine has 7 valence electrons, so they drew it with 7 dots around the side. We can see from our demonstration that there is 1 electron from the Na is going to move over to this Cl, making it Na plus and Cl minus. Since this is a positive and this is a negative, they are attracted to each other because opposites attract. So let's work on the rest of these. We have K, which is potassium. From our periodic table, we know it has 1 valence electron. We're going to add fluorine to it. Fluorine from the periodic table has 7 valence electrons. So we put 7 around. We draw a picture from this one over to here, and that tells us that we are going to have K plus because it loses 1 valence electron, and F minus because it gains 1 valence electron. If we go to Mg, Mg has 2 valence electrons. I has 7, so we draw it 7. We show that one of these valence electrons comes over here and hangs out with iodine. Iodine is now full, but Mg still has 1 left to give off. So we just add another I. And this electron is then going to come and hang out over here. So we have Mg 2 plus because it got rid of 2 electrons, I minus because the I only gained 1 electron, but since we have 2 of them, we're going to put a little 2 down here to show that we're using 2 I minus ions here. The back side of this paper jumps straight to the charged pieces. So we already know that Na has given off 1 and Cl has taken 1. So to put these together in a formula, they're going to cancel each other out, and we'll just write NaCl. On this one, we know that Ba had given off 2 electrons, so we say Ba has 2 electrons, and F took on 1 electron. So if we draw F's normal 7 and show that one of the BAs went here, we have a problem because BA still has an electron left. F is full, so we need a second F ion to take on. So we have BaF2. And we can continue this on, but there is a shortcut to do. If we have the symbol plus a number and another symbol minus a number, we can take and swap them so that it would be A, Y, B, X. If this is confusing, just look on your paper. So K, there's nothing there to switch down here, and there's a 2 here. So we'll do K2 from this 2 right here, S, nothing because it was just plus 1. Here we swap them, pretty easy because there is nothing there, Li, Br. Here we're going to put the 3 down here and the nothing here, so Al nothing, I3. When we get to number 6, it's a little interesting because what we're doing is taking 2 electrons off of the Zn and putting the 2 electrons on the S. So we have Zn with 2 electrons and S that has 6 electrons. If this electron goes here and this one goes here, we only need 1 electron apiece. So the plus 2 and the minus 2 cancel each other out, and we just need ZnS. So this is how we write binary formulas. Hope this helped.